In this question, we have given the diagram of a negative feedback system. According to this diagram, we have to give the answers to the following questions. Question number 96. In question number 96, we have to find the closed loop or transfer function of this feedback controller system. Since this is a negative feedback control system, so the formula for finding the closed loop transfer function is forward divided by 1 plus loop. If it is a positive feedback, then the formula will have the following shape: forward divided by 1 minus loop. Since it is a negative feedback, therefore the transfer function will be forward divided by 1 plus loop. Now, in forward, the forward path, this is the forward path. The direct path from input to output is called forward path. In forward path, we have 1 divided by s plus 2, 10 divided by s. So in forward path, the system contain 1 divided by s plus 2, 10 divided by s divided by 1 plus loop. Start from this point, go around and come back to this point. This is a loop. In loop, we contain 1 divided by s plus 2, 10 divided by s, and a unity feedback. We can make the feedback as 1 since it is unity feedback. So the loop contains 1 divided by s plus 2, 10 divided by s, and 1. Now let's solve the numerator. The numerator will be 10 divided by s into s plus 2 divided by the numerator 1 plus 10 divided by s into s plus 2. 10 divided by s into s plus 2 divided by s into s plus 2 plus 10 divided by s into s plus 2. This will cancel out. The transfer function will be 10 divided by s into s plus 2 plus 10, or s times s gives s square, s times 2 gives 2s plus 10. So this is the closed loop transfer function. So the correct answer is D. In question 97, it is required that if we apply a step input to the system, at what frequency the response will oscillate. So if we apply a step input to the system, then the response of the system will be like that. In this response, we have two parts. One is a transient portion, and this portion is a transient portion, and this portion is a steady state portion. You can see that in a transient response, the response oscillates and the oscillations dies out with time. So we have damping in the transient portion. So the frequency in transient response will be damped frequency. So we want to find omega d. Now let's find omega d. The relation for omega d is omega n. into square root of 1 minus zeta square. Now let's find omega n and zeta. For this, let's compare this transfer function with the standard second order transfer function. It is omega n square. Let's compare this standard transfer function with the given transfer function. We get omega n square is equal to 10. Taking a square root on both sides, we get omega n is equal to 3.16. And also compare 2 zeta omega n. In place of 2 zeta omega n, here is a 2. So 2 zeta omega n is equal to 2. 2 and 2 will cancel out. Zeta will be 1 divided by omega n. Put the value of omega n here. The result of this is 0.316. Now let's put these values in this relation. Here omega n is 3.16 times 1 minus zeta. The value of zeta is 0.316 square. Multiplying these numbers, we get the result 2.99, which is approximately 3. So the correct answer is 3 radian per second. In question 98, we have to find the peak, maximum, percent or shoot. At this point, peak or shoot occurs. So let's find the value of this point. The relation for peak or shoot is MP is equal to e raised to the power minus zeta pi divided by square root of 1 minus zeta square. Let's put the value of zeta, which is 0.316, into the value of pi is 3.14 divided by square root of 1 minus 0.316 square. By calculating these values, we get 0.35. Now the percent or shoot will be MP multiply with 100. So 0.35 into 100, it gives 35%. So the peak or shoot is 35%. In question 99, it is required to find the time required for the output to reach within 99% of the steady state. The time at which the response reaches to 99%, this time is called settling time. And settling time, the relation for settling time is 4 divided by sigma. Hence sigma is equal to zeta omega n. Let's calculate this. The value of sigma is 0.316 and the value of omega n is 3.16. By multiplying these two numbers, we get 0.998. Putting the value of sigma in this relation, 4 divided by 0.998, dividing 4 by this number, we get 4.4 second. So the time at which the response reaches a 99% of steady state value is 4.00. In a book, the answer is wrong. So thanks for watching. This video was only made for you people. For me, only like and subscribe the IK lectures.